John Marsham and I work at the University of Leeds doing research into weather and climate, and in particular clouds. And I think it's interesting to explain how I got into that because it's quite an unusual scientific discipline. So after leaving Kingswood, I did a degree at Edinburgh doing pure physics. I did that for 5 years. And after the end of about 4 years, I think like many physicists, I started to get slightly fed up with studying things that you can't see. And for me, the most exciting application was meteorology, so atmospheric science, understanding the Earth's weather and climate. And that's kind of exciting because you can look out the window and you can see what you're studying. You can look at the clouds. And it's also exciting because of climate change. So, you know, ever since I've been in education, climate change has been kind of growing in its profile in the media and its importance to humanity. Maths has often got a reputation as being a slightly dry and static subject. Well, in fact, it's not only constantly changing, but applicable to a lot of different things. I think a classic example was I was sitting on a bus and I heard some 16-year-olds behind me discussing how their big brother was going to go and do physics at Edinburgh. And their friends were like, what on earth are you going to do with that? And I did almost turn around and say, if you do physics at Edinburgh, you can probably do just about anything. But even modern computers and future computers have finite power, and things like thunderstorms are too small to be represented well. So we kind of need to understand how those things work and then use various tricks to represent them in our models. And I think a lot of scientists, when they get to university, are surprised how much maths they end up doing and how essential maths is to their studies. You know, geography, biology, ecology, all these subjects require a good understanding of maths. And maths is a very transferable skill. If you do a maths degree, it's relatively straightforward to get into biology nowadays. There's a lot of mathematical modelling biology. If you do a biology degree, you really can't get into maths. It's a sort of a one-way process, and maths is a fundamental skill for a lot of different disciplines.
My name is Nick Mills. I'm a charge nurse on the Children's Intensive Care Unit at the Leeds Teaching Hospitals Trust. That's actually 2 biggish hospitals in Leeds. We deal with children anything from newborns to the age of 16. Would that include most of you guys? Yes, I guess so. Mathematics is involved in just about everything that we do, from when we're studying and preparing for children. When we know that they're coming, we have to look at a lot of research to see how we're going to deal with them. So a practical example of how we might use it, and this is very simple, but I hope you'll understand why it's important to have some idea of mathematics. Every time we get someone in for a resuscitation event, well, imagine an adult, anybody between the age or over the age of, I don't know, 16, anyone over the weight of about 50 kilos, there is a standard protocol you have to follow. Certain amount of adrenaline, certain amount of fluid, perhaps you might defibrillate them, a certain number of joules. It's very simple with an adult. All you have to remember is a certain set of numbers. With children between the weights of, let's say, 2.5 kilos, and the largest children that we deal with, 120 kilos, and that's quite a weight difference. So the amount of adrenaline you give to a 2.5 kilo child, very different to the amount of adrenaline you might give to a 100 kilo child. You may not think that nursing is a sort of discipline that requires a lot of mathematics. Without a shadow of a doubt, it does. And if any of you are thinking of going into that sort of thing, keep up with your maths. Any former student who could be involved in the alumni project, I suspect, would have something to give. I shouldn't think there is anybody who is working who doesn't have something to say about why maths is useful.
My name's Philip Sweetnam. I work for a company called SunGuard, and my job there is installing credit risk systems for banks. I run a team that configures and installs credit risk systems for banks. Now, trying to get a bit of interactivity here, so I'm sure you're all going to answer the next question. What can you tell me about the credit crunch? Banks are supposed to be experts at handling money, handing out money, lending it to people, get it back in, that's great, but it's risky. And there are 2 big risks that banks need to manage. They're called credit risk and market risk. Market risk is basically saying you don't know how the price of the different things you're dealing with is going to change in the future. You do know how much it changed over the last few years. Suppose things got as bad as they ever did recently, how much might you lose? I've been very fortunate in my working career ever since then. Having done a degree in mathematics, it's always been a major theme in my work both doing modelling of chemical reactions and later modelling of genetic risk and now of financial risk. So this wiggly line here is how the pound-dollar exchange rate has changed over the last year. Some sort of general pattern going up and down quite rapidly called a random walk. And the sort of mathematics that I and my colleagues use is to simulate, say, 5,000 different ways in which the pound-dollar exchange rate could change over the period of a year, and say, in all those cases, what's the most I would lose if the person I've just done business with then goes out, then stops trading? I'm sure this has made some impact today. Certainly several of the students I could see some sparks of interest during my colleagues' talks and my own. It's very hard to tell, but I guess I'm optimistic.
Given the success I've had at Kingswood, I think that the main potential here is that this is a project which I think is both scalable, but also at the same time, I think schools can replicate it, and it's therefore something that I tried to take forward to see if it is indeed something that would work in other schools. So I applied for funding, and I've created a little sample of schools here in Bath, and I've been piloting with them now for nearly 12 months. I mean, I'm sure that any teacher watching this is going to say, that's great, you know, it's a really great idea. Yes, we've got parents, yes, we've got former pupils, but the one thing we haven't got is time. And I think that what this project is really about is not saying to people, look, we're trying to give you an idea, go away and do it by yourself. But actually that because we've done this small-scale pilot, what we've done is we've created a series of templates, we've created a series of guidelines and documents which we want to place so that any teacher that's interested in the project can download those documents, can maybe use some of our experiences to help them try and set up networks of former pupils and parents who are willing to come in and try to, you know, use the project in a very positive way that we've found we're able to do. The one thing that I would be really, really excited by is the possibility of trying to take this project that little step further. And really that's what this initiative is all about. I think the one thing that will resonate with teachers with this project is that we've got a new initiative being introduced in Key Stage 4, functional mathematics, where a teacher would be expected to provide the students with a context of some description, and the students then are able to try and draw some of the mathematics out of it. Now the issue very often with contextual mathematics is that there does need to be an empathy, or there does need to be a connection with the material. And I think that using case study material which is produced by former pupils is potentially a good source of that type of material, and therefore this might be a project which aligns itself to those goals. I've been very excited by the recent development with the More Maths Grads project, and the National Project Manager, Makan Singh, approached me to potentially collaborate with the project to maybe try and generate some of the case study material that could actually then sit on the More Maths Grads website in the Maths Careers section potentially. Now for me, I think that that's a major incentive for teachers, because they could then see the fruit of their labours somewhere which is a potential source of further enrichment material for students, just linking the workplace and mathematics, and hopefully altering some of those perceptions and potentially then allowing more students to then study mathematics at A level, which potentially might have the knock-on effect at degree level too.